Hi everybody, in this lesson we will see how to compare fractions that are less than 1. So let's get started right away. Suppose that we have to compare the fractions 2 over 3 and 5 over 6. So one easy way to do that is to plot both of these fractions on a number line. So in this first picture we have the unit interval from 0 to 1 divided into 3 equal parts, and therefore 2 over 3 will be this point over here, that's 2 parts away. And then for 5 over 6 we have this number line here, 0 to 1 divided into 6 equal parts, and we need 5 over 6, so we count 5 parts, and this point over here then becomes 5 over 6. And now we can see clearly that 2 over 3 is closer to 0 than 5 over 6, and therefore 2 over 3 is smaller than 5 over 6. So in this manner it's easy to compare two fractions on a number line. But what if you don't want to draw a number line to do this comparison? Is there a way to compare two fractions without drawing a number line? Yes, indeed there is. So let's take the same example of comparing 2 over 3 and 5 over 6. But now this time we will see how to compare them without drawing a number line. So what we'll do is we'll notice that the denominator here is 3 and the denominator here is 6. So we'll try to modify this first fraction so that it has the same denominator as this fraction. So to do that, we have 2 over 3. If we divide each of these parts into 2 subparts, we get 6 equal parts of the whole, and therefore we can convert this fraction 2 over 3 into the equivalent fraction 4 over 6. So now 2 over 3 is equivalent to 4 over 6, and therefore to compare 2 over 3 and 5 over 6, we can instead compare 4 over 6 and 5 over 6. So 4 over 6 is smaller than 5 over 6, and therefore 2 over 3 should also be smaller than 5 over 6. So this is the key idea here. To compare two fractions, you can convert one of them to an equivalent fraction that has the same denominator as the other fraction. So once again, the key idea is that to compare two fractions, we convert them to equivalent fractions with a common denominator. So let's take another example. Here we have to compare 5 over 9 and 7 over 12, and we don't want to draw a number line to do this comparison. So what we'll do is convert both of these fractions into equivalent fractions with the same denominator. So how do we do that? Well, the denominator here is 9 and the denominator here is 12. So we will find a common multiple of 9 and 12 and then convert both of these fractions into equivalent fractions with that denominator. So multiples of 9 are 9, 8, 27, 36, 45 and so on. Multiples of 12 are 12, 24, 36, 48 and so on. And we notice that 36 is the first common multiple. In fact, we call it the lowest common multiple, or LCM. So what we'll do now is convert both of these fractions into equivalent fractions with 36 as the denominator. So we have 5 over 9. Now to convert 9 into 36, we'll need to multiply above and below by 4. So let's do that, and this will give us 20 over 36. And then to convert 7 over 12 into an equivalent fraction with the denominator 36, we will need to multiply above and below by 3. So if we do that, we'll get 7 times 3 is 21, 12 times 3 is 36. Okay, now we can easily compare these two fractions. 20 over 36 will be less than 21 over 36, and therefore 5 over 9 is less than 7 over 12. So this is how you successfully compare two fractions. Convert them into equivalent fractions with the same denominator and do the comparison. Okay, now we have to solve this problem. Which is greater, 3 over 5 or 5 over 7? So once again, we'll first find the first common multiple or the lowest common multiple of 5 and 7. So the multiples of 5 are 5, 10, 15, 20 and so on. The multiples of 7 are 7, 14, 21, 28 and so on. And if you think about it a little bit, the first common multiple of both of these numbers is 35. So we will convert both of these fractions into equivalent fractions with the denominator 35. So 3 over 5, to convert this into a fraction with the denominator 35, we'll need to multiply above and below by 7. So this will give us 21 over 35, and then for 5 over 7 we will need to multiply above and below by 5. So this will give us 25 over 35, and now we can immediately see that 21 over 35 is less than 25 over 35, and therefore 3 over 5 is less than 5 over 7. So this is the comparison. Okay, now we just have to solve a few more problems. So here we have to compare 2 over 7 and 5 over 28. So we notice that 28 is a multiple of 7. So we can convert this into an equivalent fraction with the denominator 28 just by multiplying above and below by 4. So we will get 8 over 28, and now we can compare that with 5 over 28. So this is greater, and therefore 2 over 7 is greater than 5 over 28. What about 5 over 15 and 9 over 20? So the first common multiple of 15 and 20 is 60, and therefore we'll convert both fractions into equivalent fractions with the denominator 60. So multiply above and below by 4, you get 20 over 60, and here you multiply above and below by 3, you get 27 over 60, and therefore 5 over 15 is less than 9 over 20. What about 7 over 9 and 9 over 11? So the first common multiple of 9 and 11 is 99. So you multiply this fraction above and below by 11. So that gives you 77 over 99. And here you multiply above and below by 9. You get 81 over 99. And therefore 7 over 9 is less than 9 over 11. So that's how you can quickly compare two fractions with different denominators. Okay, now here's an applied problem. Which ribbon is longer? So this ribbon here is 9 over 12 feet long. This ribbon is 5 over 8 feet long. We just have to compare these two fractions. So we have our denominators as 12 and 8. The first common multiple of 12 and 8 is 24. So multiply above and below by 2. You get 9 over 12 equivalent to 18 over 24. Multiply above and below by 3, you get 5 over 8 as equivalent to 15 over 24, and therefore this fraction is greater. So 9 over 12 is greater than 5 over 8, and therefore this red ribbon is longer. Alright, now here's our last problem. 3 over 4 less than 7 over 10, true or false? And we have a picture here that shows 3 over 4 as this point over here, and 7 over 10 as this point over here, and 3 over 4 seems to be closer to 0 than 7 over 10, and therefore 3 over 4 should be less than 7 over 10. Is what that statement is claiming. Is it true or false? Well, let's first do the comparison of the two fractions by writing them as equivalent fractions with the same denominator. So 3 over 4 and 7 over 10. We have to compare these two fractions. So let's not look at the number line for now and just compare these two fractions by converting them into equivalent fractions. So 4 and 10, the lowest common multiple is 20. So we get to 20 by multiplying above and below by 5. So this gives me 15 over 20, and here we multiply above and below by 2. So this gives me 14 over 20. So this is actually greater than this, or 3 over 4 is actually greater than 7 over 10. So why are we getting this situation here where 3 over 4 seems to be less than 7 over 10? Well, the simple problem is that the whole interval, the length from 0 to 1, the unit interval, is not the same in the two cases. Here we have this length as our unit or our whole, but in the second situation we have a much longer length as our unit or our whole, and therefore comparing fractions of two different wholes does not make sense, and therefore this statement is actually false, and the truth is that 3 over 4 is actually greater than 7 over 10. So that's it. That's how you compare two fractions with different denominators. I hope you understood the concept. Thank you for watching.